Hey, hello, welcome back to Bazai channel. Today we are talking about NOVER, and let's keep it really simple. Normally, when we train a big reasoning model, we put judge in the middle, a human, a reward model, or some tools pipeline, and that judge gives us a score, good answer or bad one. Then we use that score to push the model to behave better. This works, but it's expensive, and it's only the region that shines in a place where you can write straight tests like max and code. Noah flipped this story. It says that if the model could be judged itself, that is what a verifier free reinforcement learning means. There is no separate reward model, no custom checker, the same model that answered the question also how to decide whether its reasoning was good or bad. So let's understand how this training the large language models is going to help to us. As we saw, like no verifier reinforcement learning, and it's enabled the incentive training on any text to text task without external verifier. What does it mean? We don't require an a middle of another external system and the tools which help us to correct our answers. Our LLM secretly can be a verifier for us, and it has its own reason for this task. So how this gonna help us to enhance our things to be here? So nowhere enable training the large language model on any given text data and any task. No verifiers, models, or rules needed. Just grounding the truth answer and policy model itself. And it can be used physics, law, medical, finance, any domains. Doesn't specify into the one or another domains. We can use this model, this training method for any given task. And let's understand how it's going to really help us. So a model gets a prompt that thinks loud, a chain of thought, and then it's give the final answers. Somewhere else, we keep a frozen copy of this model called the proxy, and we feed this proxy the prompt and the reasoning and the true answer from the dataset. The proxy asks the given reasoning doesn't have the correct answer and feel the natural. And that's how the low proximity and high reward system gonna work it here. The the lesser proximity, the lower proximity, then higher reward comes in. Let's go and understand this particular thing into the reasoning side of the ones here. So a photon is considered a point of the particle in a standard model. So discuss the theoretical implications on measurable size. And it started reasoning of this one. A photon is a fundamental particle. So it's trying to think a chain of thoughts, and then it started giving you the theoretical implementation, the implication of a photon size is an isolated static environment where its motion is halted or multifaceted and deeply rooted in a quantum mechanism and string theory accordingly. So how we derive this answer, we have a multiple reasoning, multiple thoughts which been involved, and it's gonna becomes into the final method. So let's understand the NOVA methodology. So we have a multiple fine-tuning methodologies where supervised fine-tuning when LLM gonna be fine-tuned for a specific task which is gonna be given to them, and they're gonna be a reinforcement learning with an AI in the middle, and they're gonna be a reinforcement learning, a human in the middle. So in this particular reward model, an LLM is gonna get rewarded by the human who is gonna be do a lot of annotations and clean those data, and then he started gonna give those a judge in the middle, and he started explaining with a set of rule. So he is the one. The human is gonna reward the model, and when we have the reinforcement learning with verifiable one, the AI itself will act as a verifier with rule based verifier. And for this, it's gonna be cost for us. It depends on the external side of the tools which we required. And we give the prompt and the human give those preferred annotations. But when it comes to NOVA, it's gonna work as a proxy model and a policy model within it. So it carries the ground truth with the reward proxy, and it's always gonna give the reasoning reward, and it's forward this particular policy model back uh, to the proxy model. That's where it's been more specialized in terms of like giving the accurate answers. Let me give in it how this gonna works into the real time, and I'm gonna show you the mathematical way how to we can do this in a real time. If you say like if you wanted to multiply the 37 into 24, the fine-tuned LLM will give the answer 1, 8, and 8. But with NOVA, it is trying to show how to simplify this task, which is like 37 into 24. So it's trying to take this one 20 plus 4. How that is going to work? So now I need to multiply 37 into 20, which is nothing 714. Now I'm left with 4 and 37. So all I need is to multiply 37 into 4 now. How it's gonna comes? It's now. It's gonna be a simple mathematical one where it is gonna comes to me an 8 and it's gonna comes me with 4. So now I have like 148 and 740, and then final one because it has that policy model with keep on verifying those thoughts, and it's gonna gives me the final one 8 8 8, unlike the other models which is going to be gives some random because of the fine tuning. But when it's novel, it's gonna do a multiple step processing and give the final answer to me. So unlike we have a rule based reward model, and where you have to define a bunch of rules to do that, and into the uh, uh, memorize those input output models if you're going with the supervised fine tuning model, and reinforcement human feedbacks is trying the model, but nowhere is reasoning through the perplexity as a reward and reason for the task. That's where every time when it's gonna reason it, it's a if its value is lesser perplexity, then the higher rewards it's gonna get it. The higher perplexity, and it's gonna get a lesser reward. So it is like series of the thoughts where each thought is gonna consider it, and then we will take the final output of it. The reason why the proxy says 888, very natural ending to the story. The model gets big thumbs up if it has a, a cleaner one, and that's where it's more powerful. When you compare to RLHF and verify rewards, you need to do a lot of extra stuff: human label, extra reward network, task specific verifiers, tool wiring, and those usually covers few domains. And NOVA just not need a regular supervised data, the prompt, the reference answers, and it can train on almost any text to text task, question and answers, explanation and research writing, creative writing, translations, and you can use the raw perplexity directly, and it can be noise depend how long the answer is. We ranked all the trajectories into a batch and convert the perplexity into the quantiles. Top quality region gets high score, the weak reasoning gets low scores. That makes the reward scale such a nice and smooth way of like doing it. And second, the proxy is of the policy slowly updating the copy of the policy. We blend it and average over the time. It doesn't change too fast. This means the judge stay calm while the main model learning. You don't get a wild swing or easy rewards once. And compared to the classic RL, Nova gives you no separate reward model to train, no hand-built verifiers for each domain, a rich signal that looks at the quality of reasoning and just whether the final token is matching to the one. And if you wanted to build an agent, uh, the Nova is perfect for you. The overall data set with the Nova is goes pretty much high here when it compares to the chain of thoughts with supervised fine tuning model. So the key takeaways with the Nova: trying successfully on both pre-trained and instructed models with larger gains on a stronger base model. Despite free from nature of answer, Nova still prefer objective solution instead of subjective ones. On a general reasoning, Nova have the model boundaries. It's observe and it's reason itself, and it's gonna respond to you. And we cannot hack the reward system easily because judge remains silent until the model reason itself, and finally it's gonna give those answers back to you. And it has a very good reasoning tokens, and it's gonna solve each puzzle to wise instead of like we are training or teaching the model how to catch a fish. Never train the model how to train and help them to catch a fish. So it has a process, and that's gonna build inside of it a tiny neural loop. And you started like using your code, use a tiny neural loop and fine tune that model, then powers a real agent over it. Tell me your comments on that. And if it's help, Nova feels less scary and more practical tool. Don't forget to like the video and subscribe to my Bazai for more deep dive. But